All right. Today we'll be treating analysis of variance in our series of statistics with Adelani. So we'll be looking at analysis of variance, and that is what we call ANOVA, analysis of variance. ANOVA. That is what we'll be treating about today. And the AN stands for analysis. Then the O there stands for O. Then ANOVA, the VA stands for variance. So let's continue. At times people will ask which acronym should we use, or which acronym is appropriate. Well, any of the acronyms, as you can see, is correct. Either you use all through capital, or you start with A, then all other ones small letter, or you use small letter all through. All is correct as you are led. But I can only suggest that if you're starting a word, you can use the second one. So if it's in between the words, you can use this all through small letter. Then if it is still in the middle of the word, you can use capital all through. Let me pause the video. I'm coming. So as you can see down here, all are correct. Any of them that you use, you are right to use them. All are correct. Now let's talk a bit on the history, kind of a brief history of invention of ANOVA. Remember when we talked about the t-test, it was actually invented by Gosset, who is a researcher who was pleased using it to take difference between just two groups. When we're talking about t-test is just for two groups. Then what about at those times, as researchers are having more than two groups? They found it difficult, and in the area at which they will want to test, using t-test to do is, they have to use this test to do this, and this, and this. There was a lot of potential error. And actually, it was very, very frustrating. There are errors in their calculations because they have to reuse it. So, but however, the man named Fisher, so he invented this ANOVA in the year 1918, several years ago, over a century ago. He's a British mathematician. He's a British statistician and geneticist. So he invented this ANOVA, and he used it to publish in one of his books that he titled On the Mathematical Foundation of Theoretical Statistics. And the paper was actually published in the year 1925. You can see the years in between when he invented it and when he actually published the paper on his invention. So now, what are we actually checking out when we are using ANOVA? We are actually looking out for variances, and there are two. We look at variances between the groups and within the groups. We have three groups here. You can see the group for STEM education. You see another group for ICT education. You also see another group for science, social science and humanities group. And we assume that all these ones that you are seeing, 3, 3, 4, 4, 2, 2, and 1, 1, and as it may be, those are their choices, based on strongly agree, agree, strongly disagree, and we coded them, meaning that this number 4 will be strongly agree, This three will be agree. This one will be disagree, and so on and so forth. So you can see we are looking at what is the variance within this group. You know, this group itself, this is an entity, this is another entity, and this is another entity, another entity, another entity. So we are looking at the variance within this group. And also at the same time, we will look at the variance between the groups, you know, within the STEM education group, we are looking at their variance, and we are also looking at variances within, between or among the groups. You know, this group, this group, this group, what's the variance? Then each of all these entities, what is the variance? So it's like a mesh something. We are looking at so many things at the same time. So this is a table which has to give us a score on impact of COVID on dropout rate, which we extracted from a questionnaire. So let's take a look at another one. If you look at this one, let's check out the variances in this table too. You can see that the variance that is here within this group, the variance is much. You can see that it's much. You can see 1, 1, 3, 1, 1. The variance is much. Then if you look at this one, variance is also much. But if you now look at within the group, the variances is also much. You can see that, let me go back again. You can see there is no much variance here within this group and even outside this group. Among this group, there is no much variance. If you look at the second one, there is a lot of variance, you know, a variance between 1 and 3 and 3 and 4. You can see it's a lot of variance. Variance of 1, 2, and 4, there's a lot of variance, and all of them. Then also within their groups, there are variances. So what ANOVA does for us is it checks the variances within each of all these groups and also outside among all other groups. Let's go further. The question or the big question is, which variances are we analyzing? Remember, I said it earlier, is between, among the group and also within the group. So the variances we are looking for is what? Between the groups and within the groups. You know, between, you know, among all the groups, what is the variance that is variances that are there? And also within each of all those groups, what are the variances that are there? So mathematically, it's actually a ratio, what we are looking for, you know, of the variance between the group and within the group. Is mathematically we can represent it thus. Like this F, you know, this F stands for, we can say F ratio or Fisher, but it's actually ANOVA. So we represent it with bigger F. So we now say it is a variance between the groups. You know, variance is between the groups, from group A to group B to group C. There are variance all over, variance within all the groups. You know, when you do all the calculations, you now put the between groups variance up and within groups variance down. You know, it's a big work. It's a tough work when you carry your calculator and your paper and you begin now to do the calculation. And it's simply, if we simplify it, we can say it's a square, mean square between groups. Then we also find mean square within groups. Let's assume that the mean square between groups is 20. And let's assume that square within groups is 2. So we are actually going to get 10, because this is actually what ANOVA is doing. And let's take a look at it again, and let's take an exercise. Just think over it. The question is, what are the chances of significance of F? So what are the chances of I having significance of F here? It will be very low. This will be very, very low, because if we look at, there is no much variances within the group and between the groups. You can see this one, there is no much variance here. There's no much variance. There's no much variance also here. Then between the groups, there is no much variance here. So the chances of having a significant is very low here. But let's take a look at the second one. This is very high because you can see there's variance here, there is variances here, and there is variances here. And even among all the groups, there are what? There are variances. And the chances of having is high. So let's still talk more about the ANOVA. We say we use ANOVA when comparing two or more groups. Anytime you see or you have more than two or more, you can also use it for two, but t-test is there to actually do justice for it. Or you can still use ANOVA because we use it to compare two mean or more. But the moment you have three, you have four, you have five, you use ANOVA. Then let's take a look at something that is much more important when we say way. You know, you've been hearing factorial design, you've been hearing factors, you've been hearing ways, two-way ANOVA, three-way ANOVA, four-way ANOVA, even 10-way ANOVA. What are they actually talking about? You know, in your questionnaire, you have all the moderating variables. And according to my Professor Kibukolai, we always say that any factor or any moderating variables that you don't use, please don't include it in your questionnaire. So that's the key thing. So whatever factor you know you are not looking for in your analysis, it's better not to use or to include the factor from the beginning. It's only the factors that you'll be using. Those are the ones you will include in your questionnaire. So let's take a look at all these factors. In the questionnaire, the moderating variables, we will ask something that has to do with nationality. Maybe you ask them to choose their nationality. Then here you have sex, which is gender, sex, that is male and female. So in here, let's assume for the nationality, you have four levels. Four levels in the sense that you have people from Nigeria, from Ghana, from Togo, from Benin. You know, there are four. So it means four levels are here. For sex, you only have male and female. No, there are other ones. There are other ones, but the most common ones when you say sex is male and female. Then socioeconomic status. You know, inside socioeconomic status, you could have three levels. You can have low income, medium income, and high income. Then in the area of specializations, anything could fall in for this specialization. So let's take example. Let's assume that specialization we talk in terms of their school level. Let's say law, let's say engineering, let's say technology, let's say education. So we also have four levels here. So nationality, we have four. Sex, we have two. SES, socioeconomic status, we have three. Specialization, we have four. Institution, we have two. We can say Lagos State University and also University of Lagos. So for institution here, you have two levels. Let me come over it again. These are factors, or these are moderating variables that are there in your questionnaire. So you have for nationality, where you ask them their nationality, I will say you have four here. Then four is the sense that you have Nigeria, Togo, Benin, and Ghana. So in the sex, no, we have more than two levels here for sex, but the major ones are male and female. Then social economic status, you know, the area, the how buoyant they are financially or their living status. You can have low income, high income, and middle income. So this is three levels. Specialization, it talks in terms of their area of course of study. Let's say law, engineering, technology, education. So this one is also having four levels. Then institution, we say Lagos State University and University of Lagos. This is two. So now from here, because of what you've seen, this is a number, it is now number of ways. So if we are picking only nationality for our analysis that has 4 levels, it means we are doing one way. You get that? So let me take it again. If you are taking just one of this moderating variable of all this factor, if you are using just one, it means you are doing one way. But the moment you pick 2, maybe you pick nationality and you pick specialization, you pick 2, it means you are doing what? 2 ways ANOVA. But the moment you pick 3, you are doing 3 ways ANOVA. If you pick all of them, you know they are 5. 1, 2, 3, 4, 5. So it means you are doing 5-way ANOVA. 5-way ANOVA. By the time we will be doing maybe when we'll be doing our hand hoc test, and probably when we go deeper in the ANOVA, we'll talk more on all these ways. So let's go for that, but today we are treating just 1-way ANOVA. Now, remember these 5 steps, which was also included in the t-test. No, you have just 5 simple steps. One of them is you just need to state your research questions, then you state your hypothesis and set the confidence level at which to test it. No, either you want to test it with 0.05 or 0.01. So those are your confidence level. Then you will conduct the 1-way ANOVA. Remember, we are only using 1 factor. That's why we call it 1-way. If you are using 2 factors, then we'll call it 2-way ANOVA. Then from there also you present your ANOVA table. Then finally the final step is when you state your decision on the hypothesis. And remember what we said, you either do not reject or you reject. Never say accept. But in the way of inference, you are saying you accept it, but you don't say that when you are talking in terms of hypothesis language. Now let's take a look at this research question. Now the research question says, will there be, you can see, will there be, or is there statistical significant difference among, you can see among, why am I using among? Because there are more than 1, I mean more than 2. You can see STEM education, ICT education, social science, humanities, and pure science students. You can see here that there are 4. And this one I'm taking 1, which is specialization. Let me take you back, which is specialization. This specialization, I've divided it into 4. I'm talking about the STEM education, ICT education, social science, humanities, and pure science education, and pure science students. I'm now asking, in their perception of the impact of COVID-19 on dropout rate at the end of the school year. I took this out from a questionnaire. So I'm now using 1-way ANOVA to analyze in terms of that my specialization. So, and inside the specializations, I have 4 entities, 4 levels. I have the level for STEM education, ICT education, social science, humanities, and pure science students. So I'm now looking among these 4. I'm looking at their perception of the impact of COVID-19 on dropout rate at the end of the school year. This is my research question. So I'm picking just 1, and I want to run ANOVA on it. So what I'm trying to do is just to look at the variances within the group, or within all this group, within the group of STEM education, within the group of ICT education, within the group of science on humanity, and also within the group of pure science students. Within them, there are 4 groups here. This is STEM education group 1, ICT education group 2, science humanities group 3, pure science group 4. So I'm looking at the variances within them. Then I'm also looking at the variances between all the groups together at once. And that is what ANOVA is doing for me. And I'm using one-way ANOVA because I had only picked just one factor. And the factor I had chosen or I had picked is the specialization. Remember, we said if you pick more than one, that means you are doing two-way. But I am doing one way. We are doing one way now. So let's see how we state the research question. The hypothesis. You can now see the hypothesis. You have your age and your zero down here. You make sure that it's not on the same height, but it's lower down. There will be no. I'm talking from the area of null hypothesis. There will be no statistically significant difference among. You can see the way my research questions is written. The only difference is just, is there or will there be? Every other ones are the same. If you look at it, the only thing that is just different is what? There will be no. But if you look at the research questions, I see, will there be? So take note of how to state hypotheses and research questions. Then at the lower edge, make sure that you have your confidence level or alpha level. The alpha level that I am testing this hypothesis is at 0.05. You can also use 0.01, which means you are standing on 99%. But we want to stand at 95% is why we use 0.05. Don't forget, remember your steps. We've stated the step 1, we state our research question. Number 2, we state our hypothesis and set the confidence level. Now, how do we conduct the one-way ANOVA? Is what we want to look at now. Conducting the F-test or ANOVA. What you will be seeing is still the theory of the practical. So, but after this, I will stop the video. Then I will now start again for the practical or life practical. What you are going to see is the theory of practical. Now, let's look at this now. You can see the specialization and you can see their level of agreement or level of perception. These are their names. It's more than this, but this is just one I cropped out. You can see their specialization, which I have recorded. This person is 1, this is 2, this is 3, this is 4, this is 3, this is 2, this is 2. You can see all of them, their level of specialization. In terms of ICT education, let's take a look at it. In terms of STEM education, ICT education, social science, humanities, and pure science. So those are the ones I have coded here. And this is their perception. This particular person disagree that COVID-19 on dropout rate at the end of the school year will increase. So these are their levels of disagree, agree, strongly agree, and strongly disagree, as you can have here. So what is the next thing for me to do? The next thing for me before I do my analysis or before I conduct my ANOVA, as usual, is you need to confirm your normality, you need to confirm homogeneity, and you need to confirm your random assignment. And these are the 3 that we've done in t-test, and it's also applicable in ANOVA because you are doing or running a parametric analysis. Now, how do you do that? How do you do your one-way ANOVA? It's very simple. One-way procedure using IBM SPSS. You don't just say SPSS. You call it in full. IBM SPSS. You click on the analysis. You click compare means. You check your one-way ANOVA. Then you complete the dialog box and you click OK. Then you see your analysis will be run out for you. Now we've stated our research questions. We've stated the hypothesis and set the confidence level. We've also conducted, or we've seen how to conduct the one-way ANOVA. Then how do you present your table? Is the next thing. Then the final one, you state your decision on the hypothesis. After we did the procedure, remember the homogeneity of the variance. It is good to go. Why? Because it gives us a non-significant value. This is far, far, far above 0.05. This is 0.373 after when we've done the analysis. And that is the homogeneity test is what we call Levin test. We are going to see that very soon when we go to life of the practical. And this is what is given out for us. Let's continue. Then the step 4, which is what to present one-way ANOVA result. The descriptive. The descriptive is this. So you are going to have the title of your table. You are going to write table 1, means and standard deviation of perception, score for the 4 groups. You don't just copy this out like that. Even though if you copy it out, you need to re-edit it. Re-editing means you need to change it from the way it looks like here, because this is gotten from directly from SPSS. So, and you will state that you put your standard, you stated that you have 2 decimal places to make it fun. So if you are presenting this, you will say 2.42. When you approximate all this, this is 42, 3.00, 3.36, this is 2.20, and this is 2.46. Then for your standard deviation, this is where we are actually getting all the variances from, So this one too, you will make it into 2 decimal places. This will be giving us 0.52. This will give us 0.53. This will give us 0.81. This will give us 0.79, while this will give us 0.78. So this is one of the tables that you will present. Then another table, which is the ANOVA way, one-way ANOVA result itself. You will have it to be table 2, then ANOVA summary table of their perception score. You know it is score. So you can see between groups and you can see within groups. So the analysis, these statistical tools have done the square of mean for us. Then the difference is also shown here. The mean square, this is the mean square. The F itself, this ANOVA result itself is this, and it's coming out as non-significant. That's why I wrote NS here, non-significant. And remember this shorthand, I say F3 to 37. You can see 3 to 37. Yeah, this is where you get it. Then is equal to this. This is 1.84 in 2 decimal places. That's why I have it in my colon. P is what is greater than 0.05. Or you can say P is equal to 0.16. You can say P is equal to 0.16, or you say P is greater than 0.05. Both is acceptable. Now, after which the step number 5, you state your decision on the hypothesis. You will write it out. This is your hypothesis, and this is your finding. This is your finding, then this is your decision. And below your finding is when you will write this shorthand stuff things there. Then you will also write for your decision. What is now your decision? What is now your decision is you do not reject the null hypothesis. Why? Because you stated that there will be no statistical significant difference, and truly there is no statistical significant difference. Why? Because it is greater than 0.05. So your decision will be do not reject the null hypothesis. And that is the end now for this theory of the practical of ANOVA. Let me pause and let me stop the video.